Here we're asked to evaluate each of the following expressions. And for a here, we have a limit as x approaches 3. And so our first technique to try and solve a limit with an equation is to plug that number in and see if we get an actual value here. And so when we plug in 3, we get 3 over 3 squared plus 1. 3 squared is 9. 9 plus 1 is 10. And so the limit as x approaches 3 is just 3 over 10. Same here for b, we got the limit as x approaches pi over 2. And so we're going to try plugging that in to see if we get a real number. And if we don't, we have some other things that we can try after that. So in this one, we get sine of pi over 2 over pi over 2. Sine of pi over 2 is the same thing as 90 degrees, which just means we get 1. Because that's the y value at pi over 2 radians, or 90 degrees. And then 1 divided by pi over 2 is the same thing as 1 times the reciprocal, 2 over pi. And so our limit is just equal to 2 over pi. So the third one here for c, it just says f of 3, meaning we're going to plug in 3 into this x value, which if you notice, like we already did that. We did that when we were trying to find our limit. And so we could do it again and do the math all over again, but we'll still get 3 over 10 here. Same thing with d here. We're trying to find g of pi over 2 if g of x equals sine of x over x. So we would plug in pi over 2 into this and do all the math all over again and get 2 over pi. So we kind of get the same answers here. And for E, it says compare your answers of A and C, which is the purple ones here, and then B and D, which is the red ones over here. And what can you conclude about the two functions? And what we can talk about here is the idea that since the limit points towards a number, like the left side and the right side point towards a number, and then there's a point at that x value, then that means that our function is continuous at that x value. So for a and c, that function is continuous at the x value of 3. And then same idea for the red one here, right? We have this function where we have a point at 2 over pi and a limit that points towards 2 over pi. And so therefore we get this function that is continuous at the x value of pi over 2.